Hello, and welcome to this video presentation. My name is Paul Brett. I am a Senior Software Support Analyst supporting the Transformation Extender product from IBM. The topic for this video is ITX Resource Registry Basic Operations. Feel free to reach out to me on popular social media channels at Paul Brett IBM. Today's practical demonstration is split into three parts. In the first part, I will show you how to create a simple resource registry file pair. That's an MRC and an MRN. In the second part, I will show you configuration of the various execution environments: Design Studio, Launcher, and Java API. And for the final part, I will show you examples of using the resource registry in multiple environments. For this first part of the demonstration, I'm going to show you creating the resource registry files. As you can see, on the left I have the resource registry tool open, and on the right I have a couple of browser windows open showing me the contents of the files as I create them. So let's start with the MRN file. Right click Resource and choose New. I'm going to call this file resource.mrn. I've already got a 0-byte file there, which I'm now going to overwrite. Let's expand the new file that we've created. It's empty, we have no resources and we have no servers. We are going to need to create at least one server. So I'm going to call this server prod. But I'm also going to add another 2 servers. Okay, so I have 3 servers: prod, test and design. Next I'm going to create a resource. Click Add. I'm going to call this resource input file path. Okay, that's the resource created. Now I need to assign values for each of the servers that are available. So if I open it up and say that for my design I'm going to expect the data to be in this path here. Let's make that a little bit wider so that can be seen. So we have T resource registry maps input. However, on my test environment, the testers are going to be putting all their data on the K drive in a subdirectory called input data. And finally, in production, which is in my scenario a Linux machine, everything is stored on an NFS drive under /NFS home /input_data. So there we go, 3 values for a single resource registry entry input file path. If I now save this file by clicking on Resource, right click and Save, you will note the content of the MRN file updated when I press refresh, and it's very XML-like in structure, and what I can do is I can actually copy that as an XML file and then bring it up in a browser, and it pretty formats it for me. And you can see the structure of the XML quite simply there. The virtual servers are listed first, and then every resource name is listed, and for each resource name there is a value for the server if one has been defined in the GUI. Moving on to the configuration file next. Let's right click, choose New. We're going to overwrite this resource.mrc 0-byte file. And the absolute minimum we have to do is fill in an entry for global. So that's what I'm going to do now. I'm going to click Edit, I'm going to choose Add, and then I'm going to click my MRN file. Now it's also going to ask me which is the active virtual server for this environment that I'm working on right now. Now I'm going to say in this environment, which is my Design Studio, I want the design values to come back from the resource registry entries. So we click Add. I'm now going to right click on resource and choose Save, and in this resource MRC window you will see that the content has updated. It's a long string of XML, and the XML window has also updated, and it's pretty printed for me, and you can see that the third section, the global section, is complete with a resource file pointing to resource.mrn. This is a relative reference from the MRC file to the MRN file. You could manually update this to have a full path, but for now this will work. In this section of the demo, we'll go through the minimum requirements to set up Resource Registry for the various execution environments. I'm going to open up a window in my ITX 10.1 directory, and I'm going to edit the dtx.ini file. We'll search for a string resource.mrc, and we'll find it in two places in the file. In both instances, there is a semicolon at the beginning of the line that is stopping the line from actually being active. I recommend that the semicolon is not only removed from the line, but the file reference is changed to a fully qualified path to your ITX 10 installation. As I say, it's in two places in the file, and we're going to edit both of those. There we go. Both lines in the file now have a fully qualified path to a file called resource.mrc. The next area we need to set the value for configuration file is in the Design Studio itself. So I'm going to fire that up now. When the Design Studio is up and running, from the Window menu, choose Preferences. Navigate through the Preferences section on the left to Transformation Extender and Expand, then Map and Expand, and finally Run Options. The configuration file entry needs to go in here. You can use the three-dotted button to pick the file from the directory, scroll down, point to the resource.mrc file. I'm not going to put it in yet because I want to show you what happens when that entry is not there. Move the Design Studio to one side for the moment, and we'll look at the final section, which is the launcher configuration. So if we go into Launcher Admin, here you can see that my launcher is currently running and my resource configuration file has been referenced in this box here. You can actually turn automatic startup off, and then in the Deployment Directories tab you have each MSL defined as a separate instance. It can have its own definition of an MRC file, but the global one is defined in the General tab in this box, Resource Configuration File. Now that we have the Resource Registry file configured in the three places that are required, I'm going to take you through a few runtime examples. We'll go into the Design Studio, and you'll note that I have a project called Resource Registry. Within there I have a map source file called test.mms, and then within test.mms I have a few test maps, test 1 to 5. At this point I will also open the XML versions of the Resource Registry files so that we have them on screen to refer to. MRC one first, and MRN one second. I've changed my system now so that I can edit the XML versions of the files, and every time I update them they will automatically propagate those changes back to the proper named files, resource.mrc and resource.mrn. I've done that because it's easier to edit XML style files within the Eclipse interface, because you can switch to the design view and you can expand all entries and get a nice easy view of all your different resource replacements within the Eclipse tool. You will note that I've added a few extras since the last segment where I created the files. I've got additional ones such as output file path, run map path, runtime DB, and a very interesting one that we're going to be using for test 5 called multi-line input. We'll come back to those in a moment. Okay, so if you remember, during the configuration phase I did not configure the Design Studio to use the configuration file, so when I run this map it will actually fail. Let's bring up the log file. Let's empty the content of that log file and just move it to one side for the moment. Okay, back to our map, and if we build and run, it says source not available, and now you see the log file says source not available, and it is trying to find It's put the map path on the front because it's not realised that this is actually a full path. It's not resolved that at all, and it's basically not been able to find that input at all. So let's go into the preferences now and add that configuration file in, and hopefully we should see the correct behaviour after that. Okay, let's run the map again. Map completed successfully. Now you will note that the log file shows the correct full input path. This section has come completely from the resource registry. I will show you the entry in the input card. It's %input file path %, and I will show you the entry in the MRN file. Input file path needs to change to resource registry maps input /, which matches what we've got in our input file whenever the server that we've defined is set to design, which it is in our MRC file here. So the value has been read, the input file has been read, the map has completed successfully. One last thing I want you to note is that the platform is listed as Platform API, indicating that this map has been run from Design Studio. Going to move on to Test 2 now. Test 2 has one output card, which is going to use the resource registry to write the output file to a custom path. But in the rule as well, it's going to use a resource registry entry to find the run map that we're using in a run function. Now the map that we're calling is the map that we just ran just now, the test 1. And if I build and run this map, you will note that the log changes from Platform API to run function. So this map has been run again. That means that this resource registry entry has resolved and it has managed to find the map. And you will note that the file that it's writing to, output file path in the MRN file, is writing to a custom subdirectory maps output, and in that directory we have a file called output.txt, and if we double click on that you will note it contains a 0 to indicate that the map ran successfully. I'm going to just drag that down there for a moment. I'm going to erase that and put in the word stuff just to show that it changes. Back to the map, run test 2 again, map completed successfully, and output.txt has changed to a 0 again. So there we go, that's resource registry used in input and output cards to change paths for the file adapter and also paths for run functions. You can use it in many different functions, but that's the basics. Let's go on to test 3, where I'm using the database adapter. Now this database based input card is reading, using an MDQ, it is reading an ODBC DSN and running query 1. However, in the database connection string, I'm overriding the connection so that the DSN read from the MDQ will be completely ignored and the runtime_db variable will be replaced instead. I'm going to run this. Let's just bring test3.db over here. As you can see, it's currently blank. We can close test1 log now. Test 3, when I run this map, build and run, you will note that the map completes successfully, and the database trace is showing that it's perfectly been able to connect to a data source called PostgreSQL. Now you might think, well, that's just what's in the DBL file, but if we have a look in the MDQ file with a text editor, you will note that for both design source and execution source, the connection string is the word garbage. So this MDQ alone will not work. It will not connect to a data source. It is only the fact that I have the -connect and a resource registry entry in there that it's able to connect to the correct source. And I shall prove that by just removing that temporarily and build and run again. Now we get source not available, and in the data source we get the word garbage. So when this map is designed by a map designer, they can use their MDQ file and they can have their entries in there to connect. But if they want their map to be used in multiple environments without having to make lots of changes, the -connect string here, runtime_db%, is one of the best ways to be able to do that. You distribute your maps, you distribute your MRN file that has several entries in it for the different environments, and the person implemented the runtime environment will create their own MRC file that picks the correct server, so the correct entry is pulled from the MRN file. Okay, moving on to test 4. Test 4 shows the same thing being used in a DB query statement. Let's open test4.dbl. So opening the DBL file for test 4 in preparation for running this map, let's empty the content and save it. Within our function DB query, we are using the connect string again, %runtime_db%, and this is able to pick it up and connect successfully to the database and retrieve the value that we've asked to retrieve. In this case, selecting everything from the test1 table. Right then, moving on then, the final example I want to show is test 5. Test 5 uses the echo adapter, and using the echo adapter to send in multi-line input is difficult within the Design Studio, because it's not possible to actually put carriage return line feeds into this data string here. However, but with the Resource Registry in place, %multi-line input %, and this is writing to a file called output.txt, which we shall open. Drag that over there. Back to our map. When we build and run this map is completed successfully, you will notice that the output has multi-line output that has been read from our resource file right here. The Resource Registry has taken the multi-line input variable and replaced it with the exact content in between the value tags for the design server. So there we go. There's a quick summary of using the Resource Registry in several areas of the Design Studio. Let's close all the map stuff for now and have a look at the Java API. And we will open Java Project 1, within which I have example1.java. Now this piece of Java code is going to read a map from my T drive, the same map that we were using before, test1.mmc. And because we currently have nothing defined for the Resource Registry, this map will actually fail to run. It will say source not available. So I'm going to run the example now with no changes. And down here in the console tab you can see map status source not available. So the correct way to run the Java API and initialize the Java API with a resource configuration file is to put this complete string here in place of the word null here. Now when we save and run this Java program, we should get a map completed successfully message, which we do in our console window at the bottom. So there we go. That's how you set up the Java API to use a specific Resource Registry file. The Resource Registry file string is used in the Initialize API section of the Java API. I wanted to highlight some internet pages where it describes how to set the Resource Registry for integration with third-party products. In this first tab you can see that we are looking at the instructions for integrating Resource Registry with the ITX product. It mentions a file that you need to open, customer_overrides.properties, and a line that you need to edit to point to your resource file, MRC. In this second tab you will note that these are instructions in the release notes for ITX 10, which show how to use the Resource Registry with Application Connect Enterprise. It involves editing the contents of a YAML file, server.conf.yaml, and putting in the appropriate entry to point to your configuration file. This third tab I'd like to highlight is for ITX 9, which integrates with Integration Broker. It's an older version and it uses a different method to pick the MRC file. You use the MQSI change properties command, and one of the arguments to that command is the location of the resource registry file, the MRC file again. I want to thank you for taking the time to watch this video presentation today. If you found the content interesting and informative, please hit that like button. Consider subscribing to my YouTube channel, as I release content such as this on a regular basis. Feel free to reach out to me on popular social media channels at Paul Brett IBM. Thank you.